Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. And make sure to stick until the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 25 to the power of x is equal to 50. And I want to find the value of x. So for my solution here, first start with 25 to the power of x is equal to 50. Now I'm going to be taking the log on both sides. So now I have log 25 to the power of x is equal to log 50. Now an important property of logarithms is that if I have something in the form log a to the power of b, I can actually move this exponent b to the front of the logarithm. So this is going to equal b times log a. And why this property is so important is because, so we are trying to solve for the value of x here, right? So you have 25 to the power of x is equal to 50. And we know that x is actually going to be a decimal because x can't be a whole number. So 25 to the power of 1, this is 25, and 25 to the power of 2, this is 625. So we know the value of x is going to be between 1 and 2. So at its current state, it's really hard to solve for the value of x as an exponent. But now by using this property, we're going to turn x into a real term, and now it's pretty simple to solve for x. So I have log 25 to the power of x is equal to log 50. Now I can move my exponent x to the front of the logarithm. So now I have x times log 25 is equal to log 50. Now, to solve for x, all I have to do is get rid of log 25, so I can do that by dividing both sides by log 25. So now these two cancel out, and I'll have x is equal to log 50 over log 25. So now log 50, this is the same thing as log 25 times 2. So now I have log 25 times 2 over log 25. Now if I have something in the form log a times b, this is equal to log a plus log b. So now if I have something in the form log 25 times 2, this is equal to log 25 plus log 2. And now I have this over log 25. So now this is the same thing as log 2 over log 25 plus log 25 over log 25. Now log 25 divided by log 25 is simply 1. So now I have log 2 over log 25 plus 1. And log 25, this is the same thing as log 5 squared. Now I can actually move my 2 here to the front, because remember that property. So now I have x is equal to log 2 over 2 times log 5 plus 1. Now log 2, this is equal to 0.301, and log 5, this is equal to 0.699. So now if I divide these two, I get 0.215 plus 1. So our answer is 1.215. Alright, so I have 7 to the power of x is equal to 70. So now I want to solve for the value of x. So for my solution here, 7 to the power of x is equal to 70. Now the first thing I'm going to do is I'm going to take the log on both sides. So now I have log 7 to the power of x is equal to log 70. And now an important property of logarithms is that if I have something in the form log a to the power of b, I can actually move this exponent b to the front of the logarithm. So in this case, this would equal b times log a. And the reason why this property is so important is because in this case, x here is an exponent, right? And we want to solve for the value of x. Well, solving for the value of an exponent is really hard, especially in this case, because we know our exponent is going to be a decimal or fraction. So now, if we use this property, x is going to turn into a term and not an exponent. So that's why this property is so useful. So now, I can move this exponent x to the front, so I'll have x times log 7 is equal to log 70. Now I can divide both sides by log 7. So then these two cancel out. Now we're left with x is equal to log 70 over log 7. Now log 70, this is the same thing as log 7 times 10. And now if I have something in the form log a times b, this is equal to log a plus log b. So in this case, log 7 times 10, that's going to equal log 7 plus log 10. Now I have this over log 7. Now, I'm going to go ahead and rewrite this as log 7 over log 7 plus log 10 over log 7. Now log 7 over log 7, these two can simply cancel out. So I'll be left with x is equal to 1 plus log 10 over log 7. And now the value of log 10, this is simply equal to 1. So I have x is equal to 1 plus 1 over log 7. Now log 7, you can actually find the value of this on a calculator. Log 7 is equal to 0.845. So now I have x is equal to 1 plus 1 over 0.845. So now we are going to do 1 divided by 0.845, and this is equal to approximately 1.1834. So now 1 plus 1.1834 is 2.1834. So this is my answer. Alright, so I have 2 to the power of x is equal to 5. And now I want to find the value of x. So for my solution, I first start with 2 to the power of x is equal to 5. Now what I'm going to do is I'm going to take the log on both sides. So now I have log 2 to the power of x is equal to log 5. And now I can use an important property of logarithms, which states that if I have something in the form log a to the power of b, I can move this exponent b to the front of the logarithm. So this would equal b times log a. And the reason why this property is so important is because at its current form, we're trying to solve for x, and x is an exponent here, right? And we know that x is going to be a decimal because you can't take 2 to the power of a whole number and make it equal 5. 2 to the power of 1, this is equal to 2. 2 to the power of 2, this is equal to 4. And 2 to the power of 3, this is equal to 8. So the value of x is going to be somewhere in between 2 and 3. So now what we did is we're going to use this property, and we are making x a real term. And now it's going to be really easy to solve for x. So now, from log 2 to the power of x is equal to log 5. By using this property, I can move x to the front. So now I have x times log 2 is equal to log 5. Now, solving for x is really simple. All I have to do is divide by log 2 on both sides. Now these two cancel out, and I'm left with x is equal to log 5 over log 2. Now log 5 is equal to 0.6990, and log 2, this is equal to 0.301. So now I have 0.699 over 0.301, and so this is equal to 2.32. So x is equal to 2.32. So this is our answer. Alright, so in this video, I'm solving the equation x to the power of 3 is equal to 3 to the power of 3. So to solve this, I'm going to first start by subtracting 3 to the power of 3 on both sides. So now I get x to the power of 3 minus 3 to the power of 3 is equal to 0. Now from here, if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. So this turns into x minus 3 times x squared plus 3x plus 9 is equal to 0. So now from here I get two equations. I get x minus 3 equals 0, and x squared plus 3x plus 9 is equal to 0. So obviously for x minus 3 equals 0, x is equal to 3. So this is one solution. And now for x squared plus 3x plus 9 equals 0, I can use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So this turns into negative 3 plus or minus the square root of 3 squared, which is 9, minus 4 times a, which is 1, times c, which is 9, all over 2a, so 2 times 1. And this turns into negative 3 plus or minus the square root of 9 minus 36 over 2, which is equal to negative 3 plus or minus the square root of negative 27 over 2, which is equal to negative 3 plus or minus the square root of 27 times the square root of negative 1 over 2. Now, 27 is the same thing as 9 times 3. And the square root of 9 is 3, so I get x is equal to negative 3 plus or minus 3 root 3. And the square root of negative 1 is actually equal to the imaginary number I. So these are two more solutions to this equation.